Hey folks, welcome back for another episode of Code Club. If you watched the last episode, and you should, you know that I did a deep dive on recreating a figure from the New York Times, specifically a newsletter that I receive each week. I'm showing you here the article from Francesca Parrish that is published as part of the Upshot by the New York Times. This article was talking about vaccination rates in the United States and how those rates changed because of the pandemic, right? And so this was the plot, or a version of this plot was what I made in the last episode, where things were going pretty steady, kind of right around the federal measles target of a 95% vaccination for measles, polio, and whooping cough. And then the pandemic hit and things just fell off. Well, they fell by a few percent, 2.5%, 3%. Is that a lot? I don't know. I suspect the people in the know would say any percent is too many, right? And we want everybody to be vaccinated at 100%. But I think there are a variety of reasons because of this unique historical moment, because of the pandemic, why things fell off. Anyway, enough editorializing. But what we did was we built this plot. And I would certainly encourage you to go back to the last episode and see how I went about doing that using ggplot2. Further down in this article is another plot that I thought was really cool. This plot shows the change in kindergarten measles vaccination rates by U.S. state and for the US in general. And so there's a lot going on in here that I think is just really cool. I'm always a sucker for paired data. I like arrows because it shows directionality, right? I like the legend here, right? I guess I'm really intrigued by legends. If you've watched enough of these, you know I've commented on that. But basically, the background here, this yellow, reminds me of the poverty data that we talked about a few episodes back, where I had these blue rectangles indicating when different recession events had occurred. Well, in this case, this yellowish window represents the US range, right? So what did the US look like on the right side before the pandemic, as well as after the pandemic? I thought that was cool, right? The other thing is like the US AVG is bolded. And again, the arrow shows the directionality. If it's to the left, decreasing, then it's this kind of reddish color. And if it's increasing, it was this grayish color. I like the subtle use of grid lines, and I thought it was pretty nice. Something I didn't like, because I'm from the Midwest and not everyone knows what our states are, I didn't like the abbreviations, and they seemed a bit haphazard, right? So why do you have NH versus Colo, right? Why wouldn't that be CO for Colorado, right? And so I just thought that was a bit odd. And when I redo this, I'm going to write out the full state name, I think. So we'll see how to do that using some tools baked into R. So the underlying data we talked about in the last episode, but again, you can get it from the Centers for Disease Control and Prevention. I'll have a link in the code that I'll share with you, as well as again, down below in the description. It's got a lot of great data. Last time we just looked at the national data. Today we're going to look at the national data as well as the state data. So on this page, again, titled Vaccination Coverage and Exemptions Among Kindergartners, if you click Export and then get the CSV format and get all of the data and click Download, that'll come to your Downloads directory, and then you can put that in your working directory where you're working in R. I have an R script that I'm calling vaccinationarrows.r that I've already gotten going. Again, if you want to get the code that I'm generating today, by all means, go down below in the description for today's episode and you'll get that. I've also already created a ggSave statement that has the width and height aspect ratio that matches the version that I'm trying to recreate. I've also gone ahead and popped in here this read CSV, the link to the CSV, and again, this is the link, this HTTPS link here from the data.cdc.gov, where you can get your own version. All right, so let's go ahead and load up Tidyverse. And so now we see that we've got a variety of parameters across the columns here, the vaccination, or whether or not there was an exemption, the dose, the geography type, the geography, and the school year. And then there's the estimate, which is the percent of people or percent of kindergartners that were vaccinated. And then the population size, the population surveyed, footnotes, and all sorts of other stuff. So we're going to want a couple different things. And so looking at this, let's go ahead and pipe this CSV output to do a distinct on geography. And so that gets us lots of stuff, right? But what I'm seeing is that there's like NY rest of state, NY city of New York, Let's go ahead and print all of it out. So we'll go ahead and do print n equals inf. And let's pop this up a little bit so we can kind of see all the names we have here, right? So we have Indiana, Maryland, right? We have these cities. We have District of Columbia, and Texas, City of Houston, US median, and so forth, right? And so we also have United States. And so I'm interested in the states as well as United States, right? And so I'm curious if we look at some of these. So this geography's type of states. What happens if we do a distinct on geography type? So there's states and national, which tells me that some of those cities are going to be a bit wonky, right? And so within R, there's a state.name vector that has the names of our 50 nifty United States. It doesn't have District of Columbia. The original didn't have District of Columbia, so I'm not going to worry about that. But I could use the state name to filter for geography that corresponds to those 50 states, right? And so what I could do then would be filter geography %in %, and then I'll make a vector, right? And so it'll be state.name and United States. Oh, and that printed off a bunch of stuff. So let's then go ahead and do a distinct on geography. So we'll do distinct on geography and print everything out. And so we see we've got 51 rows here. And so that's, of course, because we're going to have in here somewhere United States right there, right? So now we need to clean this up further. And let's see what's coming out of the filter so we can simplify the tibble to get the stuff we want, right? So there's vaccine exemption, dose, geography type, geography, school year. And so we're going to want like the geography, the school year, and the estimate, and we only want the measles data. So in here, I'm going to go ahead and add an and to say vaccine exemption equals MMR, because that's the vaccine for measles. And so sure enough, we now get the vaccine exemption. And so let's go ahead and pipe this to a select. So I'll do state equals geography. I know it's also got the United States in there, but whatever. And then we'll do school year equals school space year. And then we also want the estimate. And so that's going to be estimate equals estimate space % with inside parentheses. And I think that's everything we want, right? So we're going to have the state, the school year, and the estimate. Cool. All right. So now what we want to do is we want to focus on the years after the pandemic, so 23, 24, as well as the, I think, 3 years before the pandemic. And so looking at the footnote, we see pandemic is the average of 2017 through 2019 data, okay? But not all years of data were available for all states. So let's go ahead and copy those academic years, school years. And let's go ahead then and do a filter on school year %in %. And then I'll go ahead and grab this and clean that up a bit. And we'll turn this set of years into a vector of characters. All right, and put these in quotes, separate them with commas, and we should be good. And then we need another trailing parenthesis here, but we also need the 2023 to 24 data, right? So the average for pre-pandemic is going to be these 3 years, and then post-pandemic is going to be this year. So we now see for each state, we have 4 years worth of data, and I could go ahead and then count on state. Well, we see for Alaska, there's only 3, but let's go ahead and arrange by N. And we see that for Alaska and Montana, there's only 3. Let's go ahead and filter on those 2 states. So we'll do filter state equals Alaska, or state equals Montana. And so what I'm seeing for Alaska is that there's an NR. What's that? I think that's supposed to be NA. And then for Montana, we actually don't have data post-pandemic. And so that's not going to work very well. So I'm curious what our estimate values look like. And I see that we've got a character here. I think we ran into this in the last episode. So let's go ahead and mutate estimate to be a numeric. So we'll do as.numeric on estimate. And let's then go ahead and pipe that to our two states. And so now we see that it's a double and that we've got an NA. We see there's one warning in mutate, an argument estimate. It was NAs by coercion, right? So maybe what we can do instead that would be a little bit less aggressive would be to do estimate equals NA if estimate NR, okay? And so then again, let's go ahead and pipe this to these two states. Oh, and I'm missing a closed parentheses here. Now I see that NR has been turned into an NA, and then we can go ahead and continue on with our mutate, although I lost a parenthesis here. Great. So now again, our estimate is a double. Cool. So we have a problem where Montana doesn't have a post-pandemic or 23-24 estimate. I think we'll get to that. So what I'm going to do is I'm going to take the 3 pre-pandemic years, assign them to pre-pandemic, and then what we'll do is we'll get the average estimate for those 3 pre-pandemic years, right? And then when we then pivot wider, we'll get 51 rows. So each state is a row, and then we'll have the pre-pandemic and post-pandemic. And I think for like Montana, we're going to have an NA. Then we can do drop NA to remove that row for Montana. So I think we'll be okay. And again, Alaska will be okay with only one pre-pandemic date. I'm now going to make the pre-pandemic column. So I'll say period equals if else school year equals 2023 to 24. Actually, I'm going to say not equal to that. Then I'm going to call it pre-pandemic. Otherwise, we're going to put the school year. Okay, and so now we see that we have pre-pandemic and 23-24. Wonderful. And then we can then go ahead and pipe this to a summarize. Mean estimate equals mean on estimate. And we'll do it dot by. So we'll do it by the state and the period. So now what we get is we get Indiana pre-pandemic, Indiana 23-24, right? If we pipe this back and do filter state equals Montana, we then see that we only have the pre-pandemic for Montana, not the post-pandemic, right? And so now what I can do is pivot wider to get the pre-pandemic and the 2023-24 to be separate columns. So we'll do pivot wider. We'll do names from equals period, values from equals mean estimate. And so now we have the state and those two columns. Cool, right? And of course, if we then pipe this to that filter, we see we have an NA value. And so now what I can do is drop underscore NA, and we see we don't have Montana in there. And if I remove that filter, I should only have 50 rows, but I only have 47. So something's missing. So let's look again. I'm curious what we had before the drop NA. So there are 51. So that means there must be some pre-pandemic data that has NA values in it, right? And let's go ahead and print this n equals inf to get all of the rows. And so sure enough, there's Wyoming with an NA. Alaska has an NA. We knew that, right? And Delaware has an NA, right? So we can get rid of those NAs by coming back up and basically doing a drop NA after this mutate. So we can either do it there, or we can do a remove NA within mean, right? Why don't we do it within mean? We'll do na.rm equals true. And so again, what this will do is remove any NA values before calculating the mean. And so now we see Wyoming no longer has an NA value there. And if I go ahead then and drop the NAs, I now see I have 50 rows where we have, of course, lost the Montana data. So we're in good shape. And then I think this is our state CDC data. All right, and we'll go ahead and save that. And so now we're ready to take state CDC data and go ahead and make our plot. All right, so we'll go ahead and then do ggplot, AES. So we're going to use geom segment. So X is the beginning of the line, X and the end of the line. And so X is going to be the pre-pandemic. And then X end is going to be 2023 to 24. I'm not sure if those need to be in backticks or if quotes are good enough. We'll see. And then we'll need the Y to be the state. And then we'll do geom segment. So I'm feeling like this should probably be backticks rather than quotes. Very good. We now have our 50 states and we have our line segments. So there's a lot of work to do before it ends up looking like this. Maybe what we can start to do is think about the order of our data, right? So West Virginia should be on the bottom and, well, Idaho and then the US should be on top. And so I think what we want to do is go ahead and we want to turn our states into factors, and those factors are going to be ordered by the post-pandemic vaccination rate. So I'm going to create a vector of state data that has the states in the order of their 23-24 data, right? And so let's go ahead and do arrange backtick 2023 to 24. And so again, now we have things sorted. So again, Idaho is at the top, right? And so I can then call this state order. And then I can make the geography, their state, a factor by doing mutate state equals factor on state. And then my levels is going to be a vector that has United States and then state order. And so again, what this should do is reorder the state column to be a factor so that the order starts with the United States and then picks up with Idaho on down. Now, as I do this, I'm hedging a bit because I'm afraid that we might end up with the United States at the bottom and when we want it up at the top. But we'll see, and then we'll adapt. And sure enough, I don't get that. Well, I do get United States at the bottom, but I've lost everything else, right? And so that's not good. And that's because I have state order is still a tibble, right? So I need to pull the state to get a vector. I was combining a data table with a character, right, which isn't going to work. It's complaining that factor level 30 is duplicated, and I suspect it's United States, and that's because I didn't remove the United States, right? So I'll do filter state not equal to United States, and go ahead and pipe that then. And so now, sure enough, things are the reverse of what we want them to be. So we can fix that within a range. I can do minus the 23, 24. That will get it to be a descending sort. And then over here, I'll go ahead and put state order, comma, United States. And so let's run both of these chunks again. And sure enough, now we have Idaho at the top, West Virginia at the bottom, and the United States right there. Awesome. It's already starting to look a bit like this, don't you think? All right, because I always like a good win, let's go ahead and put our arrows on these lines. And so if we look at the help for geom segment, we'll see there's an arrow argument as well as an arrow fill argument, right? And so if we scroll down here to look at arrow, where's arrow? Signification of arrowheads as created by grid arrow. Let's look at that. And so arrow is right here, right? And so it tells us that we can do the angle, the length, the end that we want to have the arrow, and then the type, whether we want it open or closed. So let's go ahead and make it simple. We'll do arrow equals arrow. And wow, we now have our arrows. They need some format help, right? So let's go ahead and modify the length. So we'll do length equals unit, and I'm going to put it in terms of points. Let's start with 5 points. And then we'll do type equals closed. And actually, I seem to have just gotten that like perfect without even trying. That never happens, right? All right, so I think that looks pretty good. Now what I want to do is go ahead and color the arrow by which direction it's moving in. And so to do that, we need to create another column, I think, in our state CDC data. And so maybe we can do that up here, where I can do left, right, and we can say if, else, and we'll say pre-pandemic less than 2023, 24, then it's going to go to the right. Otherwise, it's going to go to the left. And so then we can use left, right as an aesthetic for the color. And let's go ahead and put this on separate lines. And so we now see that our left arrows are one color and our right arrows are the other color. And I got left and right going in the right direction. So I feel like I'm winning a little bit here. So now we want to customize those colors. And I'm going to zoom in a bit. And with my digital color meter, I'm going to go ahead and copy the left, plop that there. And then the right is this grayish, greenish color. And so if we put those in, yeah, it is greenish more than grayish. All right. And then we'll do scale, color, manual. And we'll then do breaks for left and right. And then values is going to be these two colors. So I'll go ahead and copy and paste or cut and paste those in. And so now we see that we have the colors that they had. I'm going to go ahead and drop the legend out. Let's do that back here. We'll do show.legend equals false. Okay, so now we've gotten rid of that legend and we have our colored arrows. Very good. I think the line thickness could be a little bit thicker. So we'll do line width equals 1.5. Okay, that's too thick. And so maybe let's try 1 and see what that gets us. One thing I'm noticing is that the arrowheads are a bit rounded, and I actually kind of like that look. And I don't know if there's a way to get the arrowheads to be more pointy, kind of like what we see for the New York Times version. But like I said, I'm happy with the way this looks, and we'll roll with that. Now what I want to do is put the state names next to the lines. And what we see is when the arrow is going to the left, the name is on the right. Yeah. And when it's going to the right, the name is on the left, right? Basically, the state name is at the pre-pandemic level. Okay. And so that's what we're going to do. And because, again, as I mentioned, I don't like these abbreviations. They feel fairly arbitrary. They're kind of abbreviations that someone in New York would do, just to be frank, speaking as a Midwesterner here. So I'm going to use the full state names. And so then once we move these state names over next to the lines, we'll then drop this y-axis. So to do that, we're going to use a geom text. And so we'll do geom text. And then we're going to add some mapping. So the label is going to be the state. And so our X is going to be the pre-pandemic level. Let's go ahead and see what this looks like. And so sure enough, it's right on top of it. All right, well, this is a start, yeah? And so we want it to be justified. And I feel like the stuff on the right, we want to be left justified. And the stuff on the left, we want to be right justified, right? And so to do that, we can come back up here to our mutate, right? And so I'll do hjust equals if else left, right, equals left. So if it's on the left, then we want it to be right justified. So that's going to be a 1. And if it's on the right, we want it to be left justified, right? And so then what we can do with this hjust is we can put it in here with our geom text, I think. So we do hjust equals hjust. And I think I did that the opposite of what I wanted, because now everything on the right is right justified rather than left justified. That's easy enough to fix. We swap these zeros and ones. Bingo. We now have our state names right next to the value. And I think we want, though, a little bit of padding between the state name and the arrow, right? So like Idaho is right up at it, and the S in Kansas is right up at it, right? Why don't we go ahead and add another column? I'll go ahead and call it X. So I'll do another if else pre-pandemic less than 2023-24, right? So this is basically the arrow going to the right, yeah? Then we're going to take estimate and we're going to move it to the left a bit, right? So let's go ahead and drop it by 1. And otherwise, we'll do estimate plus 1, right? And so then this X aesthetic, we are going to use in geom text. And I'll go ahead and put this in to the left. So we'll say X equals X. And object estimate not found. What do you mean it's not found? What did I do? Oh, right. Because that should be pre-pandemic, not estimate, right? So we'll do pre-pandemic. Let's go ahead and put this on separate lines. Now we see a bit of error between our text and our arrow. It's perhaps a little bit too much. Things are going to move once we get rid of that legend and once we get rid of that y-axis. So why don't we go ahead and do that before we finalize fiddling with the placement of that text. So again, we'll come back up to geom text and we'll do show.legend equals false. Again, that moves things over to the right pretty nicely. And now we can get rid of our y-axis because all the information here is over here. So let's do that by adding to our theme. And we'll do axis.text.y equals element blank. We'll also get rid of the ticks marks. So we'll do axis.ticks.y equals element blank. And so that looks pretty good. Let's go ahead and get rid of the axis title. We'll do axis.title.y equals element blank. And then we'll also do panel.background equals element rect. Color equals white. Also do panel.grid.minor equals element blank. And then we'll do panel.grid.major.y equals element blank. And for right now, I'm going to comment out the background color change because I want to make sure I get rid of these grid lines. And so now what we see is that we do have the major grid lines like they do. Ours are white, theirs are gray. That's fine. And so then we can go ahead and get rid of that background. And we'll also go ahead and then do panel.grid.major.x equals element line, color equals gray. And then let's go ahead and uncomment this. And I didn't get the background to be white. Why? All right, but we've got the gray grid lines. Cool. We could also remove those tick marks at the bottom, right? So let's go ahead and do axis ticks, all of them. And we can also get rid of the title on the bottom. And so we'll do axis title X and Y. All right. So now this background. Oh, I used color instead of fill. This is like the biggest pat mistake in the world. I do this all the time. So we'll do fill equals white. Color is going to be the border of the plot. Fill is the interior of the plot. Hey, there we go. What do you know? So let's go ahead and make these grid lines a little bit thinner. And again, we can do that back where we defined this. And we'll do line width equals 0.25. We could probably make them a lighter gray. And so let's do like gray 70 or gray 80. So with all that futzing and moving stuff around, we do need to move our titles to be closer to the arrows, right? And so let's come back up to where we were doing that X adjustment. And let's, instead of 1, let's make it 0.5. And so that moves it a little bit closer. We can probably go a little bit closer still. And so let's maybe make it 0.3. And I think that looks pretty good. Let's go ahead and make the font smaller. And so back up at geom text, we can do that. We can do size equals, let's do 8, and size unit equals PT. And so that shrinks it down pretty well. It could probably be like a 9. I know it doesn't seem like a big deal, but I want things to be like dead on with what they had in the original figure. And I think, yeah, that looks pretty good. Of course, their font is black, whereas mine is colored by the direction of the line. So let's go ahead and make the font black. And so back up here in geom text, we can do that. We'll do color equals black. So I'm realizing as I'm talking that I have forgotten to change my font to use the Libre Franklin font. I should do that first, right? So let's do library, show text, and then we'll do font, add Google, and it's Libre Franklin. And then we'll call it Franklin as the family. And then we'll do show text auto, and then show text opts. We'll do DPI equals 300 to get the high resolution appearance. And then in our geom text, we can do family equals Franklin and get a comma at the end here. And then within our theme, let's also do text equals element text family equals Franklin. The next thing I want to turn our attention to is this United States. So here they have US average and we have United States, so we can change the label. It's also bolded, and then we can also get into making that yellow rectangle in the background. So let's start with the label and making it bolded, right? And so I think what I'll do is in here where I define my factor, I have levels where I have United States, right? And so I'm afraid that if I go in and I change it to be US average, then things are going to get wonky with my factor. So I think I could do labels equals C state order and then US average. And hey, we got it formatted right. Cool. So factors can be really confusing and frustrating to use, but when they work, they work. All right, now we need to make that bolded and keep everything else to be a plain font face. To do that, we're going to add another column to all of this. And so here I will then do face equals if else state equals, and I think I actually here want to put United States. So if it's that, then the face is going to be bold, and otherwise it's going to be plain. And so now down here, where we have geom text, we'll then do font face equals face. And it didn't bold. So now I wonder if it should be US average. So let's go ahead and try that here. Instead of United States, US average. Bingo. Now it's bolded. So again, factors can be a little bit confusing, but hey, we got it to work, right? Now let's go ahead and put in that yellow background, right? So I think we can do that with an annotate. So we'll do annotate geom equals rect. I think that works. I'm not totally sure. And so to do this, we need xmin, xmax, ymin, ymax. And so our xmin is, again, going to be the limits on the US average. I'm going to grab these first two lines, actually. So we'll grab that, and I want the state that does equal United States. We get that. And I think I will hard code these values. So I'm going to go ahead and grab those, and then in annotate, let's pop that in. So the min is going to be 95. The max, well, I got this switched. The min is going to be 92.7, and the max is going to be 95. And then our y min is going to be 1, and our y max is going to be 50. I say that like I know what I'm talking about, but I'm not totally sure. We might have to futz with those y min, y max values. And then we'll do fill equals yellow. And I know that's also not the right shade of yellow. Hey, what do you know? We got it. But it's in the wrong place, and we need to adjust. So let's go ahead and take this, and I want this to be the very first thing because I want it to be behind the segments. Okay, now it's behind. And we also notice that it doesn't go all the way down to the bottom or to the top. And so that was set in our y min. So let's make this like 0.5 and 50.5. Let's now go ahead and so let's match this background color because it's not yellow. So instead of yellow, we'll go ahead and put in that pale color. Now let's think about our titles and our axes, right? And so the first thing to notice is that we have our numbers on the bottom, whereas they have theirs on the top. And so let's go ahead and see about how we can move that. So I believe if we look at scale x continuous, that we'll see something. There's a position equals bottom. And I wonder if we do position equals top. So let's scroll down here to look at the help for position. Where are you? There we go. For positional scales, the position of the axis, left or right for y, top or bottom for x. In here, do scale x continuous. We'll do position equals top. Okay, and we'll add that in. Awesome sauce. We now have those labels across the top, much like they do. And now what we want to do is go ahead and add percents to those labels. And if we come back to scale x continuous, and we then do labels, I think I can do scales label percent, and I need to then do the scale equals 1. So I don't, basically what I want to add is the percent sign. This is a lot of work just to add the percent sign. I mean, it's not a lot of work, but it's like, it's work, right? So now we have those percent signs, much like they have their percent signs. Now what we can do is let's go ahead and get this title, and we'll come back over to labs. We'll do x equals all this, and then we'll come down and we'll do plot.title element text face equals bold, and let's do size equals 15. So I don't see anything show up. Oh, I did x instead of title. So I think our font is a little bit too big because we're losing the right side of rates. And so let's knock that down to 14. And I think that's pretty nice. One thing I'm noticing is that we have a bit of space on the left side here that I don't think we really need. So I think the expand is on the X. So let's go ahead and do expand equals C 0, 0. And sure enough, that brings it in. But I'm seeing the nose on my arrow is getting clipped off. I'm also noticing that the, the right side of a lot of these state names are getting clipped off as well. And so why don't we change the limit? So we'll do limits equals, and I'm not sure what I want it to be, right? So state CDC data, and let's look at the minimum for both columns. So do CDC state data, I'm gonna send this to summary, and that will get us the minimum for both values. So the minimum is 79.6. So why don't we make the minimum 79 and see what that gets us, right? And so we'll do 79 to 100, all right? And that brought back that spacing, right? And so why don't we make it, instead of 79, let's do 79.5. So I think that's pretty good. Now on the right, I noticed that we're losing the percent on the 100. And so I wonder if we could increase this to maybe be like 105. We've got the label here, which we don't want. We can deal with that, but maybe we can bring it back to like 103. And so let's do that here. Good. And so we got rid of that grid line, right? And so now we see all of our state names on the right. Now with the grid lines, I noticed that there's a grid line for 95, but there's not a label for 95, right? And so we need to drop our 95 label. And so this might be where that labels percent comes back to just be like, why bother? So I'm going to drop that. And again, we want to do 80, 85, 90, and 100. So we'll do C, 80%, 85%, 90%, and then I'm going to put in blank for that 95, and then 100%. Oh, and it's complaining that breaks and labels have different lengths. Why is that? So let's go ahead and put in our breaks. We'll do breaks equals seek 80 to 100 by 5. All right, I'm not sure what that was about, but here we go. That's great. I have more space on the right than they do because I'm using the full names. I think it's good to use the full names. And plus, I would have to manually code all these abbreviations because these are just stupid abbreviations. So one thing I'm seeing as we kind of look through here is that my New York, because there wasn't a big change between pre and post-pandemic, the K is like right in the arrowhead, right? And so I think what I'll do is maybe add a space to the end of the K, to the end of the New York. And I'm probably going to end up having to do that way back up here where I defined CDC data. And so that's fine. So we'll go ahead and pipe that to a mutate on state equals, and so if else New York, oh, so it's going to be state equals New York. Then what I want it to be, I'll put 2 spaces in. Otherwise, I want it to be state. And so that didn't really do anything. I think it's ignoring my spaces. How dare they? So let's go ahead and put a period in here just to test that hypothesis. And so now I see New York has moved over, but I can kind of see the period, right? So in Unicode, there's a thing called a middle dot, which is not a period at the bottom, not a period at the top, but in the middle. And so I think what I'll do is see if we can use that instead of a period to maybe hide within the arrow, right? We're really into the weeds here, so forgive me, but hey, it's important to me. So we'll go ahead and do this. And so what I'm noticing is I can kind of see the dot there, but I think my text is on top of my arrow. It is. So let's go ahead and move the arrow down to be on top of the text, and now maybe it'll hide the text better. It hides it a little bit. I don't know if you can see it there. I can see it there, and it kind of annoys me. And so I think what I might do is looking at my nudge on the X, right? Pre-pandemic, and let's make that negative 0.25. And then what I can do is perhaps add an extra space between New York and that. And so basically we'll move the text to be closer to the segment to hide that New York period. And so now, yeah, that dot is missing. And I think this is all like an acceptable distance from the arrows. I'm pretty happy with that. Rhode Island also seems to be a bit close, but I think it will respect the leading space. And so I'll do state equals if else, state equals Rhode Island. So if it's Rhode Island, then we want an extra space before the R. Otherwise, we want the state. And so now Rhode Island has more space. This is a bit hacky, isn't it? If we wanted to do it perhaps right, maybe what we would do instead is where we're defining X here, right? I could do something a little bit more complicated to adjust the padding for, say, Rhode Island and New York and any other states that are causing us problems. But hacky is okay. I'm okay with the hacky. So let's go ahead and increase the font size on our X axis. We'll do axis text X, element text, and let's do size equals 10. And that is a little bit bigger. And I think that actually looks right on. Wow, I'm getting good at this. Let's change the color to be more of a gray color, right? And so let's do color equals gray 80. Okay, that's too light. Let's go ahead and up that to say 60. It could probably be darker still. And let's make it 40. Now what I want to do is put in a margin between my title and these numbers so that we have room to put in this legend. If we look at our plot title, I think I'll put the margin in here. We'll do margin equals margin, and we'll do B equals 20. So that brings it down a bit. We can come down a little bit more. Let's take it to 30. And so now what we want to do is be able to bring in these vertical lines to have that text annotation. And one thing I'm noticing is that the yellow goes a little bit higher than US average, right? And so let's start there. And so we define that with our rect, right? And so our ymin went up to 50.5. Let's take it up to 51.5. Maybe we'll take it down to 51 and call it good. So now what we want to do, again, is draw these vertical segments coming up from the ends of the US average, right? And so that is defined back up here in our geom rect, right? And where was geom rect? Oh, it was an annotate, right? Okay, so now we'll do annotate. We'll do geom equals segment, and quotes on that. And then we're going to have X. So it's two starting X positions and X end positions. Those are going to be the same as the X positions, right? And then Y, 2 values, and Y end, 2 positions. And so the X positions are going to be these, right? 92.7 and 95.0. So we'll copy that over to X end. And then the US is at position 51, right? And so we're going to start at position 51 for both lines. And then let's see what happens if we take it up to like 54 and 54. And so now it's complaining that discrete value is supplied to continuous scale. And that is because we are using factors. And that is annoying. And so I'm going to put in here y index equals as.numeric on state. And let's see what this looks like once we've done that. And so y index is this number. And so then what we can do is instead of using state as the aesthetic for y, we can use y index. And that shouldn't change anything. Cool. It does kind of change stuff, right? Because we are now making our y-axis a continuous scale. And so we have that expansion added to our data. So we want to remove that expansion. But that's cool because we're probably going to want to move this into chord Cartesian. So we'll do chord Cartesian and we'll do ylim. We'll do from 0.5 up to 51.5, right? I think that's basically what we had before. And we'll do expand equals false. We'll do clip equals off. And so that clip equals off, again, will allow us to show stuff outside of the plotting window. And because we've got expand equals false, we can remove it here from line 65. And so now our plot basically looks like what we had before, except what? Our lines don't come down to US average anymore. And so if we come back up here where I had annotate segment, Y is at 51. I think maybe it needs to come down to 50. Now what we want to do is go ahead and put our titles on those two stems, right? So we're going to have 2023 to 24 and then pre-pandemic. And so we'll do that with another annotate. And so I really like this annotate function. Hopefully people don't think I'm overdoing it, but I think it's been very helpful for adding kind of individual little garnishes to the plot, if you will. So our X then, so we'll do 92.7 and 95, and then our Y will be 54 and 54, and our label will be 2023 to 2024, and I believe it was all caps, pre-pandemic. And so now we want to justify it, right? So we'll go ahead and do HJust. And so the 23-24 we want to be right justified. And then the pre-pandemic we want to be left justified. And then our VJust, I think we want it to be like negative 0.2 to get it above the value. Hey, what do you know? That's pretty slick. I'm pretty happy with the vertical position. We do need to move them in a smidge. And I think we can do that by modifying HJust, right? Let's do 1.1, and then let's do negative 0.1. Oh, that moved it the wrong direction. Oops. So let's go the other direction. Let's do 0.9 and 0.1. And that actually looks pretty amazingly like spot on. We can maybe move it up just a hair. So let's go 0.3. It's great. And I'm happy with how this looks. So the font isn't right. It's still the default font. And so I keep forgetting to do that. So here, like we did down here, we need to say family equals Franklin. I think the font is perhaps a little bit too big. We'll do size equals 9 and size.unit equals PT. That will match what we have for the different state and US average labels. And that's great. I'm happy with this. This is wonderful. So on the left side here, we have the New York Times version. On the right, we have my version. Of course, my version is better, but hey, you know what? I think they're like spot on. The one subtle difference between our versions is that I spelled out the full name. You're probably sick of me talking about that. The other thing that is a little bit different is that you can see New York, West Virginia, Rhode Island. The difference between pre and post-pandemic was so small that they represented it with a dot, whereas mine has the arrowhead going in the direction. When I've looked at these differences, they're minuscule. So if we look at state CDC data, and then we look at, say, filter state equals West Virginia, the difference here is like 0.2, right? So it's really small, but it is decreasing, right? And so the direction of the arrow is correct for West Virginia. I think that's worth showing. I mean, even if that like 0.2 of the percentage point isn't meaningful, why not show it? I'll let you figure out how you would go about indicating that this was maybe with a point rather than with a segment. See if you can figure it out. I think you would use a filter to generate a data set that you would represent with the lines and the arrows, and filter to generate a separate data set with the 3 that you would use to represent with points. I'll let you figure that out. I'm tired. I think this has gone on long enough. Again, if you want to get the code that we have generated here, go down below in the description for today's episode, and you will get a link to a blog post to get this, as well as a link for the data. Please tell your friends about what we're doing here, and I hope to see you and your friends for another episode of Code Club.